Good evening, everyone, and welcome to the React Native Developers Bootcamp Cohort 5. We are in phase 2, and then today we have the third training session with one of our finest engineers in the community, Engineer Daniel Carlson. So, just for small context, Engineer Daniel Carlson, we did the first training, I think it was 2019 of the bootcamp. At that point, it wasn't called the React Native Bootcamp, but both of us, I was actually co-training with him. So he was a lead trainer and I was a co-trainer then. And later on, it became now something very big. So for that, I really always show appreciation and allow him to come back and also give back, train some people, and then also contribute. And there are other things which he's doing, but he says I should keep them as low key as possible. Without much ado, so we're going to welcome him. He's going to be taking us today on introduction to TypeScript. So you have seen JavaScript in React. You have seen some errors that maybe some of you may have noticed or not noticed, but today we are going to be specifically focusing on TypeScript. He's going to talk about what TypeScript is, why it came into being, what are the various types, how to use TypeScript to transfer from JavaScript to TypeScript and back and forth. And he's going to be doing a lot of examples so that we can be able to see. So it's going to take 1 hour and explain every concept with the code. At some point, you may want to, if you want to ask a question, you can raise your hand or you can drop it in the comment section. He'll be looking at it from time to time. But then there's going to be a 30 minutes afterwards for question and answer. And then after that, we are done with the day. So 1 hour, 30-minute session, so we don't spend so much time here. So without much ado, please, with a very thunderous set of emojis, let's welcome Engineer Daniel Carlson. Carlson, over to you. Please keep the emojis coming till he starts talking. Yeah.
Yes.
Yes, we can hear you.
Everybody. So today we'll be doing TypeScript, like Martin said. So it's good to be back. Always good to be here, sharing the little I know, the up and comers. So today we'll be talking about TypeScript. Let me share my screen now. Let me know when you can see my screen. Okay, so TypeScript basically is JavaScript, superset of JavaScript. So some people will describe TypeScript as JavaScript with types. As I'm sure you must have noticed from you could do React or React Native. React Native, I guess.
Primarily React. Just focus on React. They didn't go deep in React Native, so React for now.
Okay. So as I'm sure you must have noticed in your JavaScript and React, you must have been getting some errors which you could have found probably while you were writing your code. Maybe because you got the types wrong, and then when you run your code, you're getting behavior which you don't really understand, you don't really get. So TypeScript definitely helps with that. So like I said, TypeScript is just JavaScript with types. It is built by Microsoft now. So you should go to GitHub. You can see the repository there. It is open source. And you also have like a playground where you can try out stuff in TypeScript. So it is literally JavaScript with types. So you can still have, so everything you do in your normal JavaScript will work in TypeScript because, like I said, it is a superset of JavaScript. So in TypeScript, you have JavaScript. And the reason why many people would have or would add TypeScript to a project, as you go further, you realize that a lot of production-ready projects are done with TypeScript rather than just JavaScript because it helps with debugging because of the static typing. You get feedback, you get error feedback right in your editors if you're using VS Code and whatever. you'll get feedback almost immediately when you're using TypeScript. The only difference with TypeScript and JavaScript is it requires, especially when you're in strict mode. A lot of people add TypeScript to their project, but they don't make it, or they don't add it in the strict mode, because in the strict mode you'll be required to actually write TypeScript, because some people just, if you convert any JavaScript file to a .ts file and you use the TypeScript transpiler, it's still going to work, because you notice whenever I click run, it says executed transpile TypeScript. Because again, if you want to run your JavaScript code and you wrote TypeScript code, that code needs to be converted back to JavaScript. So that process is done by a transpiler or a compiler, as you see when you go for that in TypeScript. But for now, you just need to know that whenever you run the code, it is converted back to JavaScript. So TypeScript does allow us create types or specify the types of the variables that we have. So whenever you're declaring variables in JavaScript, you would usually use something like var. Let's see this.
Carlson, can you increase the size of the thing one again? Can increase it again, please, so that it's quite again, like 2 more times. Yes, this is good. Thank you. And I think you can drag off that the video preview of the thing. If you just click on close, you should remove it.
Yeah, if I click on close, it's going to close the browser.
Okay. You can just drag. Okay, cool.
Oh yeah, sorry about that. So in JavaScript, you would usually do something like this. As I'm sure you would have done this by now. So this is basic JavaScript. In TypeScript, you have 2 ways of declaring variables. You have the let. Please, as we go along, you can just ask. You can ask your questions in the comment section, like you would have comments. So what this does for us is these 2 variables, the n and the answer variable, are treated differently, because n is considered a variable that you can change. So later on, you can do this, but because we declare this other variable as a const or constant, you can change it later. So if I were to do something like this in your VS Code, you would immediately get this, which tells you cannot assign to answer because it is a constant. So this is what TypeScript does for you. It adds types. So if I created a variable like this, and I said this variable is going to be a number, and then later on I did something like this, you see I get an error immediately. So if I was building a project in JavaScript, let's say I was building my React app and I had a back end, for me to see this error in JavaScript, I would have to probably make a request to the back end, and then the back end tells me you provided unprocessable data or whatever. Then I'll have to go in there and debug and figure out where my issue is from. But with TypeScript, because I've already said that this is going to be a number, as soon as I put a string in there, it gives me these red squiggly lines in my editor almost immediately. So this is what TypeScript does for you. It has static typing. It converts or it changes JavaScript into a static typed programming language. So now you can actually do stuff without fear of silent failures, because JavaScript has a lot of silent failures. And that's why you notice a lot of people will see coding in JavaScript is like an extreme sport, because there's so many ways your code can fail and you don't even realize that. But if you're using TypeScript, you would avoid and prevent all of that. So TypeScript has the normal data types that you would have. You can also say value. You can also say it's going to be a string. You can also say we already declared name before. So we can say a value is going to be a string. You can also say it's going to be a truthy value, in which case here you can put true or false. So you cannot do something like this. You will get an error or you get a complaint from your browser telling you this is wrong. And if you run it with a transpiler or a compiler, like I mentioned, you are going to get an error. Like it's not JavaScript will allow this to work. JavaScript will figure out a way to convert a Boolean to a number or a number to a Boolean, whatever. But TypeScript won't allow that. It's going to tell you this is wrong. This variable can only take a number. That's the importance of TypeScript. TypeScript can also do what we call inference. So in this case, it infers the type of the variable you are using. So if I were to do something like this, TypeScript is going to immediately infer that cure is a string because I declared and defines this variable with a string. So if I came later on and I did this, I'm going to get an error. I'm going to get a complaint. And if you hover over it, you see type number is not assignable to type string. So this is what TypeScript does for us. So these are the basic types. So you have our number, string, Boolean. What's the last one? So these are the simple or the primary types. As we go further, you would see arrays. You can also tell TypeScript that a variable is going to be an array. So you see, it already tells me this is an error because it will tell me type this is not assignable to type this. So here we have an array of numbers, but here we have an array, just an array. So you have to tell TypeScript that this is going to be an array of, how we do it, of numbers. So you can either specifically write out the type, or you can just do this and TypeScript will figure out the type for you. But the issue now is, if you do it like this, it's not really an issue, but if you do it like this, it's going to tell you, if you try and do this, you're going to get an issue. Yeah, it is complaining because we already have this up here. So remember I said everything you do in JavaScript still works in TypeScript. That's why the var is still valid in TypeScript. So if I take that out, you still get the error because it now says type number is not assignable to type this. So this is an array. So if you wanted to do an array of numbers, it will tell you this. And now you can no longer reassign this, you get an error. If you wanted to do strings, so this is how you would generally create an array of strings in TypeScript. So with function types, you can also specify the type of arguments that your function requires. So if I create a function, for example, let's call it addition, and it takes two numbers, in TypeScript I can say, okay, this is going to be, right? So this tells us that we are creating a function called add, and that function is going to take two numbers that are of the type number. So if I came here and I did I came here and I did this, you see it's going to complain. It's going to tell me argument of type string is not assignable to arguments of type number, because our function expects 2 numbers, not 2 strings. So this is what TypeScript does for you. It also allows you to specify the return type of a function. If I do another function called, let's do a function that takes a number and then returns a Boolean. So this function, you see, if I don't add anything to it, it's already complaining and telling me my function returns nothing, which is undefined, but this function must return a Boolean value. That's what this is basically saying.
Yes, Carlson, sorry for breaking your flow. I just wanted to confirm with the participants if they are okay with everything, if they're okay with the speed, just to be sure. Okay. I'm seeing only 2 people confirming. Okay. Okay. Thank you. I just wanted to confirm that everybody was following and just to realign. Thank you. You can continue.
Okay. So you can specify the type of function returns. So in this case, our function must return either a true or false. So if I do this, it fixes the issue. So here, if we're checking if a number is even, how do you do that again? Modulo division, right? So if I do a, so what this does is, you would also see, don't think too much about this, but basically what this does is it converts this expression here to a Boolean expression. That's what this basically does. And because our function requires a Boolean value as its return type, we must have a return type here as a Boolean expression. So normally you would write this as so you could write this as this, which basically just checks if a number is even or odd, right? What else can TypeScript do for us? So with TypeScript, it also helps when you're dealing with objects. So for example, if you have a function that greets a user, for example, we can say this is our user, and we are returning so basically this is a function that takes an object of type. So if I hover over it, so this also helps you with your debugging or reading code, because it keeps these types, and your browser can, or your editor, sorry, I don't know why I keep saying browser. Your editor can show you what that object is about. So here you see this is a parameter, which is of type user, and the user has an attribute called name, which is a string. And our function here, we can write that out and to say, okay, this function returns a string. We mustn't do this. Remember, I spoke about inference. So from the return type, TypeScript is going to figure out that, okay, this function returns a string, and then it's going to act accordingly. Any questions up until this point? Okay, if there are no questions, TypeScript can also allow us to create our own types. So for example, if I do something like this, if I wanted to create a new variable based on this type, I could say this is it's a user. So what this expects is, right? So basically, here what we have done is we have created a type user, And we are saying that that type should have 3 attributes: a name, an ID, and an email. The reason why we have the question mark by email is to say it is optional. So you notice that here when I created a user, I did not give it an email, and Typescript did not complain. That's because I said email is optional. So in our case, user.email is either a string or undefined. So when I don't define it like this, if I were to print or console.log, it will tell me undefined, right? That's what. But if I try to do something like it's going to tell me this doesn't exist on this type. So I'm trying to use an attribute that does not exist on that particular type. And another reason why you would do something like this is when you're typing, if I were to do u.this, you see the editor will show me all of the attributes that are available to me. So I know I wouldn't make a mistake. So when you have like very few values like this, it doesn't look like much. If you are dealing with a type that had maybe say 25 different attributes, this quickly helps you prevent human errors, because it will be difficult for you to make a mistake, because every time you do this, you can just choose from the list. And you see that if you go down this list, it shows you what each one is. So the email is a string or undefined, the ID is a number, and then the name is a string. If I added another value here and I said, I did something like this. Okay. So if we added another thing like this, address, what this says is address is missing, because if you see, we now get the squiggly line under this, and you tell you property address is missing in this type. That's just it. And if I do quick fix, you say add the missing properties. This is how your VS Code should work. Then it's going to add it for us like that. So this is the power of TypeScript. It allows us to create our own types. You can also do something along the lines of, so now in my code, whenever I use user ID, TypeScript is going to understand that it is a number. So if I created a different type, let's see, user, right? This is perfectly fine, because the compiler or the interpreter knows or understands that this user ID here represents a number. But if you're reading the code, this makes more sense than having just number here. This is a user ID. If later on I wanted to change this into a UUID, this will work fine, right? Okay, well, So TypeScript also allows us to do what we call unions, right? If I'm building, or if I'm receiving data from an API and I want to keep track of the status. So for example, when I'm waiting for the request to come through, we'll have a loading phase. When the request comes through successfully, we'll have a success phase. And if it fails, we'll have an error phase, right? This is basically what promises are. So I can make this into a type in TypeScript by doing a union. So how you do a union is I'll do status. So this is a union. What this says is status can only be one of 3 types: loading, success, or error. So if for example, I have a function now, let's say we have a render function and it takes the status. So this is our function. So here we can check for the 3 status. So if we do something like so in TypeScript, you usually get sometimes when you create a function, you usually get this error which says not all code parts return a value. This is because this, if you pass something else to this function, it might not have all of these conditions might fail, and then it will not return anything, and that's why TypeScript is complaining here. So usually you do something like this, just so you can have a value. So this is what TypeScript does for us. It has allowed us to create a union of 3 different strings or 3 different values we want to compare as the same. And you can also do unions with anything, right? So unions basically combine multiple values to form one value. So here, status here represents loading, success, or error. So we can also do something like so this is also a union. We have combined 2 objects. And the first object has an attribute OK with a Boolean value true, and then it provides the data, which is the ID and the name. The second is false value, false, and then it has as the other attribute error, which is a string. And so if I were to write a function to handle our response from our back end, we would specify that, okay, this is going to be this. So now it is possible for us to do this. You see, TypeScript already shows me the various attributes I can use with the argument or the parameter that you pass to this function. So this helps me prevent unnecessary errors or typing errors or whatever. So even here I can do res.data.name. This is perfectly valid. If this fails, then I know it is an error. So I can also do res. And you see it already shows me those properties that I can choose from. Then I can do this. This is what TypeScript does for you. You can do a multitude of this and build a lot of things for yourself. And so all of this basically makes it very easy for you to write tests, because if I'm testing this function, I can test it against this type, because I can say, okay, this function, first of all, first test will be, does it receive and treat with the right parameter? Is the parameter of type API response? Because if we don't have this, if we have just our JavaScript, this is just going to succeed. And writing tests for this will be a pain, because we would have to be very, very, very specific when we're writing tests in JavaScript. But if you have your static typing available, it's easy to pinpoint the things you want to test or target. And this helps you with a lot of the stuff that you'll be working on. Does anybody have a question up to this point? So in React, you usually have your props. Let's do a button prop that would have label and on click. So basically, we are saying this our button component that we are building. If you build your button component like this, you will then pass a label on click function with disabled, which by default is false, and you see this is button props. Right? This is, I'm sure this should be familiar to all of us if you're building your React project. So it's going to complain here because this is not CSX, but you get the idea of what I'm trying to show you. And then the level. So this basically says, so this is the simple React component that we have created. So be mindful of the fact that when you're using TypeScript with React, you will not use JSX, you will use TSX. So instead of naming your file button.jsx, because you're using TypeScript, you will do button.tsx because you are now using TypeScript. That tells the compiler or the interpreter or whatever that you're going to be writing TypeScript code. Again, take note that you can write your normal JavaScript and it will still work. But if you create a TypeScript project in strict mode, it will require that you give a lot of the things that you are doing specific types, right? So this is just a button, and we are saying that this button is going to be taking a label, an on-click, and an optional disabled feature. And then we are going to pass it to our actual button HTML, and then we display like this. So this is a lot of what you're going to be seeing as you go forward. So the on-click function here, you can see we have an empty function, and then it returns a void. So void is a valid type in TypeScript. Undefined is also valid. Null is also valid. They pretty much mean the same thing, but they are not exactly the same thing. Going into that is going to be another lesson on its own. But just know that for now, these three mean pretty much the same thing. So they are valid. So here we are saying that onClick is going to be a function that takes no parameters and returns nothing. So whatever function we pass here is just going to be run, and then we're going to keep it moving. So if you hover over this, you'll see it still has the type of as empty function returning void. But if you were to do something like type of on click, it will tell you what exactly this is, which is a function. So you could still have written this as function. And it would be perfectly fine. So this is what we call, these are not primary types, they are composite types. So you have functions, objects, arrays. So when we did our arrays, yeah, you could do something like this is going to be an array, but you have to specify array of whatever it is you're writing. If you wanted an object, this is also valid. But you will rarely ever say this. That's why I did not show you this, but you should also know that it exists like that in case you come into it. People usually do something like this instead to specify an array, to do something like this to specify objects, unions, and so on and so forth. So you have unions, you can also have intersections. So in TypeScript, you will also see something like, somebody will also create something like this and then do something like, let's say, any, right? Should not have this after your default values. Right? What this basically means is this data can be of any value. So basically this is like declaring a value in JavaScript, but here we are not restricting it to any specific thing. So the person calling our button can pass data as a string, a number, a boolean, an array, an object, an array of objects, object of objects, and so on and so forth. And this button will still accept all of this because we specified and said data is of type any. But again, if you're in strict mode, this is going to complain. This is going to give you an error and tell you that any is not accepted in this project. There are a lot of projects where people don't want to see any in it. So you should always try to specify your types in your projects when you are working. Any questions up until this point? So if there's no questions, I'll just show you an example of how you would generally use TypeScript in an actual project. So this project, we are building a project and we are requesting for types from the back end. So you see in this project, we defined types and you take note that the file names are .cs instead of .js. And if I was creating a component, for example, it would be .csx. So this is a simple React component that you would know. So this is, you would see a lot of the stuff I just explained. So you see this export type phone string, which is just a string, but it helps in readability. It helps with documentation. When you're documenting stuff, you can get basic info just by declaring types for it. So this is a whole type that we have created, and you can see there's multiple types. So when you're working with TypeScript, you're going to see a lot of projects like this, which is basically what I just explained. So you see in here, we are creating a type called login values, which is just an object type with email password. The email is an email string, which if you go to the top, you see email string is actually just a string. And then the password is another string. You can see, so I mentioned unions. You also have intersections. So this is what we call an intersection. So we are creating sign-up values and using sign-up clinic info, which is a type, sign-up owner info, which is a type, and sign-up terms, which is a type. So all of these join up to create one value. And if you were to see how those were used, you would see that whenever you are making a request, for example, you can specify that a response or whatever is going to be of that type. Are we together? So this is basically, so you can see the data here is sign up clinic request, which is just a combination of multiple values put into one. But this basically helps us because if we are building a large project, we want to see these errors pop up immediately because you don't want to have to like run your code, make the request, it fails, then you go in there trying to figure out what's wrong before you come and realize that you didn't pass the proper types. If you have your strong typing already implemented, TypeScript will immediately tell you that, hey man, there is a problem with this thing that you are doing. That is a basic intro to TypeScript. Let me see if I've forgotten anything for the basics. So if you already have a JavaScript project, you can make it a TypeScript project. So if you go now to your JavaScript project and you change all of the files to .tsx instead of .jsx, and then you add a transpiler to your project, you're good to go. You don't need to change any of the code. It's still going to work. And then you can slowly transition to TypeScript. You can slowly start defining the types, which means at the beginning of adding TypeScript to your JavaScript project, you wouldn't set it up in the strict mode because it's going to complain about a lot of stuff in your JavaScript project. Yes, even when you think you are writing the best JavaScript possible, as soon as you add TypeScript in there, you're going to realize that there's a lot of stuff that you might have missed. Just because we are humans, we are bound to make errors. So this is what TypeScript adds to your JavaScript ecosystem. Because you will notice whenever you want to tell somebody, hey man, let's do this project in JavaScript, they're like, nah, we'd rather go with something with strong types. So TypeScript is what gives JavaScript the strong types that people always talk about. So that's it for our introduction to TypeScript. Any questions?
Wow, that was very
sorry.
swift.
Let me just read the question. I just want to confirm you say we declare variable without the type. The TypeScript compiler determines the type. Yes, so that's what we call in inference. So TypeScript can infer the type based on what you are doing. But take note that once it has inferred this type, you can no longer do something else with it. So if I were to do, for example, get students course, and I did something like this, take note that I can no longer do this. It's going to give me an error because number is not assignable to type string because when we defined and when we declared this variable, we basically said it was going to be a string. So you can see that even when I hover over it, it tells me that student is a string. So that's inference. It infers the type from what you are doing. If I were to do something like right? If you hover over this, you see TypeScript already tells you, it has already inferred the type of what school is. So if I came now and I was doing something like console.log and I did school. You see, it shows me the things that I have available to me that will not give me an error. So if I came here and I started doing something like this, it's just immediately going to tell me this is wrong. There's an issue here. But if you were in JavaScript, this will not give you an error right now. This will not give you an error right now. It will do what we refer to as it will silently fail. And because because JavaScript will just check, is there an email attribute in this object? No, there isn't. You're just going to do console.log undefined and then sit quiet. And then you're there trying to figure out what's happening. Meanwhile, you got the wrong attributes. So in this case, there's two ways to fix this. You either add an email attribute here, or you can take it out and use one of the already available attributes that are there. What if I want to change the type of variable I had declared? Yes, you can do casting. Casting is possible. We would advise that you don't, because if you start using a variable as a string and then later on you want to change it to a number, it means you probably didn't think about it properly, and you should probably go back and change the initial declaration of that variable. Because if you're working again on a big project and they started using an API response, for example, and you came in and said this should be a string, that's a lot of refactoring. But if you do decide to make that move, immediately you change the API response, for example, to a string, all of the files that use API response as API response will immediately show up as having issues, like they'll become red in your VS Code, and then you can go in there and change them. So you don't even need to start figuring out where this variable was used. Your editor will figure that out for you. TypeScript and your editor will figure all of that out and then help you with it.
Okay.
Any other questions?
Yeah, I wanted to ask, I don't know if you talked about when a variable can have multiple types.
Oh yes. So you can also, yeah, rather than casting, that's another way you can do it. You can also declare a variable and say it will have multiple types. So I can do something like this, and you see that it fixes the issue that we were having. Because yeah, I've said student is either a string or a number. So in this case, TypeScript we're expecting a string or a number. So if I now come here and I say, okay, student is equal to false, TypeScript will say, okay, this is now an issue because it does not match the type that I expected. So in this case, I can either add up here and say, okay, we can also take booleans in this value. So this is still part of what we call the union, right? This is still a union because I can just do something like and then I'll remove all of this and just do this, right? So this tells TypeScript that we are expecting student type, and student type here is string, number, or boolean. So as you go further in your learning, you're also going to learn about things like partials, infer, refer, and so on and so forth, generics in TypeScript. But this is the basics of TypeScript. With this, you can do a lot of stuff with TypeScript. In JavaScript, when you add a string and a number, JS converts the number to string and concatenates. Will it work the same in TypeScript? It depends on what you are doing. So if you just let's so I do this, and then I do so our playground is in some sort of strict mode. So that's why you see here they always say implicitly has any type. So in cases like this, by default, TypeScript will give it an any type, but it doesn't like the any type. It gives it an any type because it understands that a lot of people coming from JavaScript don't always know the types. So sometimes you can go to your browser and click infer parameter types from usage. So basically, this is telling your editor to look at how you have used those variables to infer the types. So if I click this, it's going to update this, right? But again, you don't want, so what JavaScript does, it makes sense, but that's what we generally refer to as unintentional behaviors. That's not what you would usually want. You don't want your editor trying to figure out the type that you are trying to do. So it will work how you expect it to work. So you convert the string to a number, the number to a string, whatever is happening, and then give you an answer. But you don't want that, right? You don't want that. So in JavaScript, it concatenates, yes. In TypeScript, if you do it like this, it's also going to concatenate. But if you have this, so if you do something like this, and you do this, it's going to still do the concatenation. But here it is explicit. So it's and if you pass, if I do addition and I do 5 and 6, let's see what it give us. So you see here it does the concatenation for us. It does us 56 because here we explicitly said it should. If we take this out, we leave it as any. And we run this, nothing will change because here it is playing the role of your JavaScript. So here it is figuring shit out. It is trying to figure out, okay, A is this, B is this. Let's see what we can do with this information. But if we had this, then we will get an error here and tell you this is not what we expect. So you can still do your casting like this, and that works. But whatever you do, addition should receive 2 numbers. That's the basics of it. Any other questions?
Thank you very much, Carlson. Please let's show some love with the emojis on the screen for Carlson. So I think today we are actually going fast and it's nice. At least we're going to still have the recording on YouTube. So before we go, Carlson, please, do you have any like a take-home task for them to do, something to set up, maybe anything to do around this so that at least they are able to practice with the skills that you've given them?
Sure.
Okay, that would be really appreciated.
You already created React projects with Vite, right?
Yes, they already created React project. I think they use create React app, but I can send them the Vite link to create also.
Yeah, so the same way you create a project with Vite, React project, you can create a TypeScript project. So if you go to the TypeScript tutorial, it'll show you how to get your Vite project started. So you see that when you run this, then it's going to ask you what framework. If you select
We cannot see your screen. We cannot see your screen.
Is that it? So if you go to the TypeScript website, let me just copy the link and share with you.
Thank you.
So that basically walks you through how to set up a TypeScript project with it, then run it. So project name, you put your project name, framework is vanilla. So you're using your normal JavaScript, and then the variant you're going to be using is TypeScript. And then it's going to create the project for you. Then you can run the project how you would normally run your React project. And then it creates this structure. This is the structure it creates for you. So what you can do in here is basically what we've been doing on our playground. So if you open your main.ts file, you would have an empty file there where you can add stuff and then see it work in real time, because the Vite will already convert it to what it needs to be. Let me see what mini task I can give. So this will just be, I'll just write it in the chat. So basically, that's just a task that says you should implement the type function. If you implement with the type, if you implement with the type, that takes a list of you. If you implement a function that takes a list of users, filters the active users, and then returns the emails of those users that it has filtered. And it should only return emails that are valid. So what this is saying is there'll probably be users in there without emails, and then you need to figure that out in your function. So but doing this will basically get you to create your own types, because looking at this, I see you already need to create a user type, and then your user type has to have a couple of stuff in there. What else? We showed you how to declare functions or define functions and their types and so on and so forth. So this is a simple exercise that will help you get started with TypeScript. Let me see if I can come up with another one. So this one, they should have a status called active. So for a user to be active, they should have a status called active. So if we're going by something like this, no, that's really the assignment. But basically, there should be a status in there that says active. So, or is active. If it's active, it's false. Then you can, or you can just put a string there, active. It's just up to you. It's just up to how you want to do it.
Yeah.
Let
Carlson,
me
I think this will do. Can you paste the code on a paste bin so they can have access to that?
Yes.
So you can paste it on paste bin and then send the link, and I'll also drop it on the group. Like everything in that which you have done today, just everything.
How do you say stuff in this thing again? Category. Syntax writing. Okay, how do I share this now?
I think if you just copy this link, it should link to this browser.
I'm sure I have another. So if you're feeling adventurous, this is a more React. What just happened? Oh, went under. So basically, this says create a user badge component, which takes as props a name and online, which is optional, which is Boolean, and then show a dot if said person is online. So that's a React specific task for TypeScript.
Carlson, please can you copy and send it again? I just
The link to the paste bin.
No, the last task that you put. Can you just copy and paste it back on that same chat? I mistakenly left the chat. Okay, cool. I want to copy it and send to the group.
Okay. Are there any other questions?
Okay. If there are no questions, this is the end of the session for today. Okay. Johan, go ahead. Keep it short.
Good evening. Good evening, Sir Daniel. The session was really nice. Please, I just want to know, when are we supposed to submit this task?
2 days.
Okay.
Yes, every task has 2 days.
I think you just read what we did. I was about to say like today, but it's 2 days, so 2 days first.
Yeah, since they have another tomorrow, so we always give 2 days before the next task for submission.
Okay, 2 days it is.
Yes, People see that people think that I'm wild. You have seen wild man. He wants you
I'm
to
not.
give it
No, it's
today.
not wild. It's not being wild. If you just read the stuff we did today, like you should be able to knock that out in like an hour or so. But
Yeah. Okay. This takes us to the end of the session. Thank you very much, Carlson. Thank you, everyone who has been able to make it to this time. And let's have a great evening and see us tomorrow, 7 p.m. And we're going to be looking at API calls. Good night to everyone. Bye bye.
good night, everybody.